I've always wanted to be a chemist, ever since the age of 12, when I stumbled across in my father's bookcase the Pelican Book of Explosives. And at that point I decided I wanted to become a chemist, before I really knew what chemistry was.
I was kind of torn between a lot of different courses, but after talking to my chemistry teacher at school, I thought, yeah, this is what I want to study.
It sounds fairly trivial, but I've always enjoyed chemistry.
I always wanted to know why some things did what it did, and with chemistry you get a lot of that understanding.
I'm sufficiently stubborn that I've stuck to it and become a chemist, even though I hasten to add I've never had anything to do with explosives. Chemistry is the study of everything around us, the world around us, the universe around us, even from the point of view of atoms and molecules.
You're expected to have this sort of database of knowledge about chemistry, but then the course itself is very much about applying it to problems, explaining sort of trends in facts and figures.
The philosophy of the course is to put together all the different bits of science that a chemist needs to know to understand how molecules work.
We have to do organic, inorganic and physical chemistry for all 3 years.
It sounds like a bad thing, but by the time you get to your 4th year, it means that you're able to have a decent conversation with any other chemist about what their research is.
The core part of the chemistry course is pretty rigid, and the core part of the course is the whole of the 1st year, and most of the 2nd year and a bit of the 3rd year.
Generally there's lectures every day, 9 till 11, and then some days I will have practicals, so I'll be in labs, and other days I'll either be doing tutorial work or having a tutorial or doing my lab reports.
The main misperception about the Oxford course is that it's a very theoretical course and that practicals are not important. And I don't think that's true. We are trying to teach students to solve problems, but problems are not just paper problems.
I had a problem with the maths course. It just wasn't clicking for me. So I talked to my tutors at the end of my 1st term, and I had extra maths tutorials, and then I got a really good mark on my maths exam at the end of the year, which I wouldn't have got if I just stayed silent and struggled on with it.
It makes you very competent at handling numbers and handling facts and gearing those facts in a way to make them applicable to a problem.
We teach in a holistic way and we examine in a holistic way, so at the end of each year you get a set of exams which covers the whole course up to that point.
A lot of other chemistry courses are modular, and they have modular exams, so they learn things for an exam and then they forget about it after they've had the exam, whereas that's completely different in Oxford. The 3rd year exams, you could be asked about anything from all 3 years of Oxford.
Real problems aren't modular. Real problems in the real world, you have to use your imagination to solve them, and you have to link together all sorts of things you may not have thought of as being relevant.
A lot of courses, they sort of put the research over the 3 years in different places. It's very nice to have it as a separate unit and then have a published piece of work at the end.
In the 4th year, students can in principle work in a lab abroad, they can in principle work in a lab in industry, so long as the project that they've selected fits.
So that is the time then you when you decide this is what I want, this area of chemistry is what I want to study, and then you do that for a full year, so you kind of become the expert in that area.
So every master's course in the country has a 4th year with a major project in it, but in every other course you haven't done enough chemistry yet really to be doing research, and you have to do other courses alongside it. Whereas in Oxford you actually have done enough chemistry to go straight into a research lab and spend the whole year doing research. The research lab facilities in Oxford are probably the best in the UK in any university, and quite possibly the best in the world in any university. It has NMR spectrometers for hands-on use on every floor. It has gas chromatography, mass spectrometry routinely available, and it's just a really well set up lab.
I haven't had to buy that many textbooks because they already have them there, and we can have them out for the whole term.
The tutorial system is great. I mean, there really is no other place where you can get one-on-one time with leading professionals in chemistry, leading experts in their subject, and they're willing to sit you down for 2 hours a week and explain problems to you and have a conversation about chemistry, which is wonderful.
The fact that I can teach my students in usually pairs means that I can really focus on what they need, and it means that I get to know them really well.
You've got a lot of time to ask them questions, and they've got a lot of time to kind of push you and make you think about chemistry in a different way and like really try and stretch your understanding, which I think is great.
You've got to get used very, very quickly to just taking the initiative to finding the results, the answers yourself, rather than being given them. And that's something which I've enjoyed and I've become a lot better at.
There's always a point where people think, oh, I'm not supposed to be here. But one thing I wish I'd known is that a lot of people think that. So you're not the only one sitting there thinking that maybe my tutors made the wrong choice letting me in.
It's a great joy to teach Oxford students because they stretch me as much as I stretch them. And every time a student asks me a question I can't answer, I really enjoy it.
I tend to find that like my tutor will say something, like explain something in a different way to the way they explained it in the lectures, and I'm just like, oh, I totally understand it now, this makes so much sense, whereas it didn't before. It's like an instant like light bulb moment.
I used to think that, you know, teaching was done in classrooms, with a teacher standing at the board, but not anymore.
I was tempted to stay closer to home and go to a university in the northeast, but I thought I'd regret not coming to Oxford more than I'd regret not going to one of the other universities that I applied to.
Obviously you need to have knowledge in the first place, but you need to be able to do something with it, and that's really what we're looking for. So we'll start with things that you probably have come across before or ought to be able to work out for yourself, and then we'll probe how far we can take you with it.
They want to see what you're like when they throw numbers at you, throw a bit of data at you, but they ease you in. They're not monsters.
The best thing to do is to read more than one A-level syllabus. We don't expect you to know lots of abstruse things that are outside the syllabus, but we do expect you to know the stuff that you've been taught, and we expect you to understand it.
Anything you said on your personal statement will be fair game in the interview. They might not ask you anything about your personal statement, but if you said something, if you decided that you love a certain chemist, you've written that on your personal statement, that he's inspired you, definitely look over that again, because if they ask you about it and you're just like,
Lots of people come out of the interview feeling that they've really blown it because they've broken down at various points. But that's what we want to do. We want to see what happens when you break down. Can you recover yourself? Can you pick up on hints? Can you work things out for yourself? We want to see your brain work.
By the time I got my letter, I knew exactly what time the postman came. I just remember opening my letter and was like, I couldn't believe it because I thought my interview had gone terribly. I thought there was no chance I was in. So I was like, yay!
That's one of the best things about chemistry. It leaves so many doors open once you finish.
Most of our students stay in chemistry in some form or other. Many of them go on to further degrees in chemistry or into the chemical industry. There are major chemical industries in the country, and they're all looking for good, well-qualified chemists.
I have a year of 8 people. Of that, 3 of them are going to study DPhils, take on further study. The rest of them are going to work as professionals in a wide variety of fields, from law to banking to management consulting. You can do anything with it.
One of our students became Prime Minister. That's Margaret Thatcher. one of our students flies a jet fighter in the Air Force.
I'm using my 4th year as a kind of test to see if maybe I want to go into research.
I may not be reading through my chemistry textbooks over the next 20 years, but I'll certainly be taking the skills that I've learned when I did read those chemistry textbooks and applying them to life outside of chemistry.
I think definitely something with science. It hasn't killed my love for science at all. So I definitely want to use my chemistry knowledge in the rest of my life.
If you're sitting there thinking, yeah, I really could see myself reading about chemistry for 4 years, then you're going to love it. You really are.